Hi, my name is Kunal. I am here to explain about the instruction and instruction sequencing of a computer. Introduction of instruction and instruction sequences are in a computer we need to have capabilities of data transferring, arithmetic logic and program sequencing, input and output transformation of computer. I am first of all the first thing of method is RTN, means register transfer notation. The register transfer notation is a is used to have identify the location of a symbolic name and adding and standing for its hardware binary addressing. Name of addressing memory locations may be LOC, PLACE, and A and variable 2. Processing register names may be R0, R5, R2, or R3, something. Input and output registers may be data in and out status. Contents of a memory locations as that as are donated by placing from square brackets around the name of the locations. For examples, it is given in the slide. This type of notation is also known as RTN, register transfer notation. Next thing is assembly language notation. RTN notation easy to understand but cannot be used to represent a machine instruction. RTN notation is easy to understand, but it is not used in many conditions. In many conditions, the assembly language is used more, and it is represents as a machine instruction of a program. The processor understand only binary format. We need to use a notation such as could be converted into machine language. For this, a new format called assembly language is used. For a machine language, to convert a language to a machine language, the assembly language is the main thing to use. Here, for an example, move LOC R1 is equals to R1 brackets ILOC is example for assembly language notation. It is given in the slide, you can see that. And here we use English like a words called as mix of representatives and operations uniquely. And the other basic instructions types called like that: three address instruction format, two address instruction format, one addressing instruction format, and zero addressing instruction format. In three addressing instruction format, C is equals to A plus B is a high level instruction to add the values of two variables like A and B, and to assign the sum of third variable called C. When the if statement is compiled, each of these variable is assigned to a location in the memory. The contents of these locations represents the values of three variables. Hence, the above instruction requires the action called as C equals to square bracket A plus square bracket B. To carry out above the instruction, the contents of memory locations A and B are fetched from the main memory and transferred into a processor. Sum is compiled, result is sent back to a memory and stored in a location C. The same action is performed at single machine instructions. Operands like A and B called the source operand C is called as destination operations. And the next slide is given as two two addresses instructions. In two addresses instructions, like that operation source destination. An alternative method to use a two instruction of the form called as like that operation source and destinations. For an example, add A comma B. Such performs the operation A B is equals to square bracket A plus square bracket B. It is given in the slide. B is not in this 3 addressing instruction previsions value, B is not destroyed, but in 2 addresses instruction prevision value, B is destroyed. This problem is solved by using the another two-way addresses instruction to copy the contents of one memory location into another memory location. Now C is equal to bracket A plus B is equivalent to move B comma C and add A comma C. Like that, the examples is given in the slide, and the next another types is called as one addresses instructions. Instead of mentioning the second operand, it is understood to be a unique location. A processor, which is usually called as accumulator, is used for this purpose. Example, add a, load a, and store a is given in the slide. And add a means that the contents of memory locations a are added to a contents of accumulator, and the load a copies the contents of memory location a into accumulator. Store a copies the contents of accumulator to a location a. This depends instruction operand may be source on destination. The next slide is zero addressing instruction. Here locations are operands are defined implicitly. Such instructions are found in machines that store operands in an instruction in structure called push down stack. Here push down stack, the stack is a list of data elements. It is a list of data elements, usually words or bytes. In such these elements can be added or removed through the top of the stack by following the LIFO, last in first out